Hi everyone, thanks for joining us for today's webinar on Bomay to alcohol. So essentially when I joined the wine industry, and I'm sure when everyone else did, I was told a general rule of thumb, which is simply that for every Bomay of sugar in juice, we'll give 1% of alcohol in the finished wine. And this is probably one of the most enduring rules of thumb and I'd say myths out there. Unfortunately, the problem is that it is only a rule of thumb. It works relatively well for juices that are around 10 or 11 Bomay, but as soon as we start going away from that, we start to see a few things. So there's a lot of other things we need to take in consideration when we're estimating alcohol. And what I'm hoping to do today is give you a bit of an overview of what those things are and an idea of how you can possibly do a bit better in the way of estimates. So the first thing that we'll introduce is that we're using these natural living little organisms called yeast to do all the work. They're a wonderful thing, but they're not all born equal. They're not all the same. And some work that was done way back in 2008 and earlier at the AWRI really quantified this quite well. And here you can see on the screen a list of different yeasts. And what I just wanted to point out is that if you look at something like AWRI 796, which is a really common yeast, we see that it can generate 12.4% alcohol, but when we compare exactly the same ferment using exactly the same juice using N96, we can get an alcohol of 12.9. Now, that's a 0.5% difference in the actual ethanol generated, and from an overall percentage term, it's not a huge amount. From a metabolic perspective, it's not a gigantic difference, but from a winemaking perspective, 0.5% of alcohol is a lot. And so that's the first thing we need to keep in mind, that yeast can produce different amounts of alcohol, and it's because they use slightly different pathways. They generate different amounts of glycerol, different amounts of acetic acid, as you can see in this table. This was a really good article back from 2008, and I suggest you contact the library and have a look at it if you want a little bit more information about this trial and what it means. It's because it's great work and it gives that extra bit of information through there. Okay. The other important thing to keep in note is this is one of the strategies that's being pursued by researchers looking at different ways to get lower alcohol wine. So they're looking at different kinds of yeast, not necessarily Saccharomyces cerevisiae, but co-inoculating or starting ferments off with those so they can look for things that don't produce quite as much alcohol, and that's one strategy to get those numbers down a bit. But for what we're doing here, the important bit is that different yeasts can give different amounts of alcohol, not hugely different, but enough to make a difference to our final wine. So once we get past that little bit and we know, all right, not all the yeast are the same, then we've got to deal with one of our old favorites, which is the Bomay scale. The Brick scale is essentially equivalent, so you can use them interchangeably, but we'll stick to Bomay for this talk. Now, when we were just looking at those charts, that table in the slide before, we were seeing the amounts of alcohol generated as grams per litre of sugar, and that's how we tend to refer to concentrations of sugar, etc., in grams per litre. Problem is, when we're using the Bomay scale, which was originally developed for salt solutions, and that's another whole long story about how we ended up using that, it actually measures in mass per mass, or grams per kilogram, lots of different ways to refer to that, but it is fundamentally different that we're doing a mass per mass versus a mass per volume. Now, for dilute solutions, which is what we deal with in chemistry quite often, that doesn't make a lot of difference. But juice is not a dilute solution. You're talking about 250 to 300 grams per litre. So there's a lot of something there, and that actually massively changes the densities we're talking about, which is why we can use the Bomay or brick scale to actually measure the amount of dissolved solids in juice. So to give an idea of how big a difference it means, 1 kilogram of juice at 10 Bomay has 0.933 litres of volume, whereas at 15 Bomay, a 1 kilogram sample only has 0.898. Now, that's only 4% difference, but when we start converting that to the amount of sugar that we can see in the process, that's at 10 Bomay, we're looking at about 0.7% alcohol if we're using some of the information on the table before. And when we talk about the next one, sorry, technical problems, we're looking at about 30 gram per litre difference of sugar, or about 1.8% alcohol. So the real upshot of this is that as we change Bomay, the conversion between Bomay and grams per litre actually changes. So it's not a linear conversion you can do along the scale. So if you're going to use Bomay to measure the amount of total dissolved solids, and not necessarily sugar, we'll get to that next, then you have to be aware that if you want to do a conversion to grams per litre, that conversion is going to change as you move along the Bomay scale. So the upshot of this is, for using a pure sugar solution, we would, and AW was 796, we would see at 10 Bomay about 11.4% alcohol generated. If we get up to 14 Bomay, we see 16.6 for that same yeast. Now remember, this is talking about pure sugar solutions. This is not what you're going to get from a juice, but it gives you an idea of the scale of difference that can be made by just this error that comes around in the grams per litre conversion. So it's really important that the first thing we get our head around after we understand the differences in yeast is that we're not looking at a scale where sugar concentration per litre varies linearly with Bomay. So you need to think about that as well. It becomes really important when you consider that more and more we're seeing fruit up in the 14 for final total dissolved solids. Okay, so we see these really quite large amounts of sugar there. It's actually higher than we probably expected based on just our first reading of Bomay. What else can go wrong in the whole process? Well, the first thing that we do need to remember is that juice is not a pure water sugar solution. There's actually a lot more to it. So when we're measuring Bomay, we're measuring total dissolved solids, and sugar is by far the biggest component of that, but it's the only components. And so the other things that we can see in there are things like the organic acids. They can be there 3 to 15 grams per litre. Phenolics, 0.1 to 1 gram per litre. Pectins, 0.1 to 0.8. Nitrogenous compounds, 0.2 to 2 grams. Inorganic components, 3 to 5 grams, so that's all the various salts, sulfates, chlorides, all those sort of things. And they all contribute to that measurement we're making with Bomay, the total dissolved solids. And the scary bit of this is that it will vary with vintage, variety, and ripeness. So you've got this variable that's there that includes the titratable acidity that we measure, but it's got a fair few other things in there. So when we're measuring Bomay, we've got this other non-fermentables part of it there, which realistically can easily add 0.3 to 1.3% alcohol difference based on pure Bomay. Now it tends to reduce the amount of predicted alcohol, so it works in the opposite direction to the error in the Bomay scale we saw before. So it does add that other confounding factor there. If you're interested in more information on what all these other components are in there, these numbers came straight from the Viticulture Volume 1 by Brian Coombe and Peter Dry. Another thing that thought I'd just throw in at this point is the problem that not all the sugars actually get measured in our initial Bomay measurement. There's quite a bit of sugar that's tied up to other wine compounds, so it's actually not soluble. They're actually tied up in this flesh, they're tied up in the skins, all those sort of things. Often as what we call glycosides, but they can be tied up in many, many different forms. And that's why we can see during the fermentation, we'll see more sugars actually released. And so it's not unusual for us to see, levels as high as 10 or more grams per litre of extra sugar being added to the ferment during the fermentation process, as the enzymes involved in fermentation actually break down these compounds. So there are sugars in there that can get involved which we're not actually measuring in the original process. Much more an issue for reds than it is for whites, sorry. Obviously in whites, because we're pressing out the juice straight from the flesh and then doing the fermentation, we're seeing most of that in the total dissolved solids, but for reds we can see an actual jump in sugar that's quite significant. The next thing which pains me to talk about being a chemist and a person who does a lot of time measuring things is how good is your testing. And look, we have lots of great ways of measuring Brix and Bomay and SG these days. We have either good old hydrometers, or we have nice new electronic density meters. They all work very well, but the reality is their accuracy in juices is only around plus or minus 0.2. Now, if you're doing it in perfect, ideal lab conditions using sugar solutions and that, it's actually much better than that. But we're talking about juices out in the cellar doing real measurements, and I've had a number of people say to me that plus or minus 0.2 is probably a bit optimistic, but it's a good number. It's what I find that good lab staff and good cellar staff can manage in the testing, but you are looking at a 0.2 difference. And if you're not doing it well, so if you're not getting rid of all the bubbles or the solids and that before you do your measurements, it can be a fair bit worse than that. So important to keep in mind. So just measurements alone, we can see a plus or minus error of about 0.2% alcohol, just because it's inherently difficult to measure. So once again, that's when you add that to the error based around the changes in between Bomay and grams per litre, the errors introduced by the different yeast conversion factors, it all starts to add up to quite a lot. Often asked, can we just use glucose fructose measurements instead? Yep, lots of advantages to do that. That's also extra work, but there's still, when you're talking about juices, about a 5% error, which is quite a lot on juice values, and that's because you have to take those juices, dilute them down a long way to actually make them measurable by either HPLC or enzymatic testing, but it doesn't solve all our problems if we go to GF measurements. One other reminder is to really accurately predict your alcohol or try to get good numbers through there, you need to use the final juice just before the ferment, and preferably the cold settled juice, or in the case of reds, that stuff that's had a chance to extract out a little bit. Trying to predict from vineyard results or from results straight out of the press straight before it's had a chance to settle and all those sort of things introduces heaps of errors, and it is going to make your life a lot more difficult. So the cleaner the juice is, the closer to ferment, the more accurate your prediction is going to be. And there are other factors. As if it wasn't enough, I've just introduced all these other things in there. Stuff like fermenter size can make a difference. It actually changes the dynamics of the ferment to a certain extent. Fermenter shape can have an impact. In the beer industry, they see different conversion factors quite often because using different shaped fermenters, scary by itself. How often you do pump overs and how the pump over is set up, simply because you're adding a lot of air to the ferment there, and so you can see a lot of blow off of alcohol. You can actually remove alcohol that way. Surprising enough, in really extreme cases, that can be 0.5% of alcohol, even more. Ferment temperature is going to change the way the yeasts function, and so you're going to change the conversion factors there. Water additions. We don't make water additions to Australian wine, obviously, but when you're doing, there is a certain small amount allowed around the addition of additives and that sort of thing, but they actually change the dynamics of your percentage of non-fermentable solids to your actual sugar, etc. So that'll change the conversion rates in there. Press conditions for reds, how hard you press out will decide how much extra sugar you quite often get from skins and flesh and all those sort of things. It's not unusual to see a jump between the last Bomay test, or the last sugar test before you press out, and the sugar test after you press out. I was looking at a ferment just the other day that saw, from last year, that saw a 1 Bomay jump just from after pressing out, so pretty significant. And the degree of bound sugars on reds, keep coming back to that. It's a bit of a fly in the ointment when you're trying to do predictions for red alcohol. Final one, degree of aeration. Yeah, that gets in there as well. It's a bit like the pump over thing. If you're pumping a lot of air through there, you're going to change the amount of alcohol that gets forced off in the process. So what does it look like? If we take all this sort of stuff into account, what do the calculations look like? And so here, I'm going to take you through a couple of quick equations which aren't too scary. Well, actually, I'm lying. To me, they look very scary. I'm not a mathematician, but what we really need to do is take the alcohol, calculate that, work out the number of mils of alcohol generated, then we work out the amount of water that's actually in the ferment, because the amount of water will decide the amount of concentration. So you don't, in a 1 kilo or 1 litre of ferment, you don't have 1 litre of water. The sugar does take up a fair bit of space, so you need to calculate that. And then you can chuck all that into a simple equation which works out the amount of final volume alcohol. But the problems we get are, well, firstly, we are actually ignoring, there's reason I'm saying this is a simplified alcohol conversion. There are a few other physical and chemical factors that come into this, like partial molar volumes. They don't tend to make that big an impact in the final numbers, so I'm going to ignore them for this simplified version. The non-simplified version just sucks, so we won't go there. That's the technical term for that, by the way. So yeast conversion factors, we can look those up or calculate those. So they're a thing that we can put into that from these equations. But the other non-fermentable solids, in other words, we're measuring TA, so that's part of the non-fermentable solid, so we can get that bit. But the pectins, the tannins, the other phenolics, the salts and all that, we don't actually measure those at any stage, so we really don't know any numbers for that. And then there's always what I call the fermenter correction, which is what's the impacts of our different fermenters going to have, and we don't really have a standard number for those. So even with these equations, we've got quite a few assumptions and averages that we're taking place in there. So how big a difference does it make? If I use those equations and some average numbers there, if we're talking about something at about 11 Bomay, we're probably only seeing a 0.6 difference, potential alcohol difference from calculated to the rule of thumb alcohol. So we see it go up by about 0.6, which is probably within keeping of what we see quite often out there. But as you go up, because that difference in the Bomay scale becomes quite a lot bigger as you go higher, you can see that the potential alcohol difference, taking all these into account, is still about 1.6%. So for fruit around 14 Bomay, it is quite possible to see it ferment out into something like 15.6% in a really seriously converting ferment. Now, please don't take these as the numbers that you're going to see. This is only one specific case where I've chosen a yeast, I've chosen a factor for the non-fermentable solids, better known as a fudge factor, and a fudge factor for the impact of fermenters. I've actually included no fermenter factor in these ones just to show how big a difference it can make. So it can make a really, really big difference, but it's going to depend on the actual ferment style, ferment temperature, and how you do it. So what can you do in this whole process? It's not a lost cause. It really isn't. You can do it much more simply than trying to use those sort of equations. And essentially, the best way to approach it, if you do want to try to get more accurate alcohol, is to just put together essentially a three-part equation, which is what I kind of call the simplified alcohol equation. I'm not very creative when it comes to these sort of namings. So to get percentage alcohol, we take the real sugar, we multiply it by yeast conversion factor. You're going to need something like that, and then the fudge factor for the impacts of fermenters and other little bits and pieces in the process. Now you can use reference values for these compounds, but for the best results, it really is worthwhile trying to develop them for your own situation. And if you do actually go to the effort of developing some of these things, you will actually get quite accurate numbers. Final reminder, these do vary from vintage to vintage. The real sugar number will vary because of because of the non-fermentable solids. Yeast conversion factor, that varies a little bit, but not so much, and not so much with the fermenter factor. So how would you go about calculating the real sugar value? Well, rather than just using the straight Bomay, calculate the sugar content, and there's a pretty simple equation for that. Looks like a lot, but it's 18 times the Bomay times specific gravity of the juice, which you can just look up on a table, times 0.9982, which is literally just the density of water at 20 degrees. All these things are assuming that you're doing the measurements correctly for 20 degrees Celsius. And then you just subtract the non-fermentable portion from that. Now, the non-fermentable portion, Rankin in his book Making Good Wine suggests using a average figure of 20 grams per litre. Alternatively, you can just subtract a TA and then use a bit of a fudge factor for the other fermentables. Once again, not that hard to develop something that works for you, but remember the amount of non-fermentables will change from vintage to vintage, so you should keep that in mind as you do your calculations. Better still than doing that calculation, actually measure the glucose fructose for the first few juices of each variety in the beginning of vintage and use that to come up with your generalized factor for how much GF you're going to get per Bomay. It's actually quite easy to develop a standard table or process around that, and that's going to nicely get rid of the issue of trying to work out exactly what the non-fermentable component's going to be. Now, the yeast conversion factor, the simple option is to use the ones that we saw in slide 3, which give you the amount of alcohol per gram of sugar. That's the easy one to use for that. Or you can use an average figure of around 16.4 grams sugar per 1% alcohol. That's right in the middle of that table that we showed early on in slide 3. That gives you a reasonable thing. You're going to be within 0.2, 0.3 of the yeast conversion factor for that, in alcohol. So that works pretty well. But once again, a better option is have a look at measure the glucose fructose for some juices and then use the values you get from those ferments for your yeast to come up with your own alcohol conversion factor. If you make that effort through there, it'll take into account all the things that affect your ferment, such as temperature, ferment style, all those sort of things. Relatively easy numbers to develop. You can, as I said, you can use the average if you want, because it only makes a 0.2, 0.3 plus or minus difference, but you can get a lot more accurate if you have those, especially if you're starting to use some of the more unusual yeasts out there, and especially the non-sac yeast. It'll give you a better idea of where you're going to be with those. Then the fermenter factor, well, the only real option for that is to develop it over a bit of time. So if you take into account the real sugar, your yeast conversion rates, get those nailed down, then you've just got to develop what, I call it the fermenter factor, but essentially it's a bit of a fudge factor. It doesn't have a huge impact all the time, especially for whites. It's quite a small process. However, for some red ferments where you've got all the issues about sugars released during pressing off and during fermentation, the impacts of pump overs and all that, you really do need to get a bit of a feel for where that one's coming. So if you take all these things into account, you can develop a more accurate version than you'll get from the Bomay system. And you'll very quickly be able to get one where you say, well, this is the typical value we're going to get. You'll get a better picture of where it's going to vary from vintage to vintage and what different vintage impacts will have in those, because they are quite significant, especially when you're talking about the different TAs we're going to see from different fruit through the process, but it'll work quite well. But it is still in the end only an estimate. Okay, it's a much better estimate than the one we were talking about where we just take Bomay and say that's going to be the alcohol, but it is only an estimate. Okay, so always keep that in mind. What you should be targeting is get it down to, within 0.2, 0.3% prediction, and that's quite doable. But please don't try to get to the second or third decimal place, because you've got no hope in hell. Okay, if you do manage to do that, you're doing very, very well. One final thing, to try to help people do that, we're going to run a trial this year where essentially what we're going to do is get a heap of juice samples from people, measure the actual real sugars in them, and use that to help us develop, a generalized set of rules about what the fermentable to non-fermentable fractions are going to be, so people can use those numbers to predict it, build it into a calculator, and make that available to everyone online. To help us do that, what we need is help from you guys. So we're after samples, usually probably 50 ml frozen juice samples, but importantly, what we need are juice samples where people have done their own Bomay measurements at the beginning, so we can work out how big an impact that has, and have also fermented those juices in isolation with specific yeast through to the final ferment, so we can see what final alcohol you get, and we'll pull all those things into some equations and hopefully develop an online calculator which will just give you a lot more help in developing this sort of process. So if you're interested in being involved in that, please contact us and we will talk to you about how you can be involved. So that's the end of the talk. Right at the end is a table which I'll make available for people if they go to the record webinar. That's just the calculations of bricks to Bomay to bricks to specific gravity, the changes in what 1 kilo juice actually volume is, what the total dissolved solids are, not the sugar, because that's a straight calculation there, and then the grams per litre. So if you don't really want to use those equations, that's just a bit of a quick cheat sheet for you. But use the table very much at your own risk. There's lots of assumptions and stuff made in that when I did it, but it's based around the equations I showed you a bit earlier. So yeah, I hope that gives people a bit clearer idea of what's happening when you're trying to predict alcohol. And yeah, thank you very much for your time and for listening.
Okay, thanks very much, Eric. We'll roll from here straight into a Q&A. So Eric's going to stick around and answer any questions you may have. So start sending them through now. Quick reminder, if you don't know how to ask a question, the easiest way is probably to type it into the bottom section of your control panel. You can also speak with Eric directly, if you have a microphone, click the raise hand button and I'll unmute your mic and you can have a chat. There's also the option of sending questions via email. You can do this at infoservices@awri.com.au. So we don't have any questions as yet, but we'll stick around for at least another minute or so, and hopefully we'll get a few come through.
Hi there. Just got a question from one person. Brix has the same issues as Bomay measurement, except that it is linear. The relationship between Brix and Bomay is reasonably linear, but it's exactly the same thing. You can change all the equations that I use in that and replace the number 18 with 10 and get a reasonable estimate through that part of the process. Brix and Bomay are both mass per mass scales. They work relatively equivalently. You're just using a different scale for those. So it's no more linear in relationship to the gram per litre relationship with gram per gram, but it is interchangeable with the Bomay thing. So you can use the same equations, just change 18 for 10. There are minor other differences between them, but they're relatively small.
Thanks for your question there, Heath. Looks at this stage like that's the only question we're going to get today. So we'll start to wrap up from here. Firstly, I'd just like to thank Eric for presenting and for staying calm during those technical difficulties we were having earlier. Thank you also to everyone who attended and took part in today's session. For attendees, you will receive a follow-up email which will have a link to the recording. That email will also have a link to a survey. The next AWR webinar is in April, the 14th of April, and we have Chris Penfold from the University of Adelaide doing a cover crop update. If you'd like to register for this webinar, please visit the AWR website. That's all we have for today. Thank you again for attending, and I look forward to seeing you in the next AWRI webinar.